All right, good morning. Today is May the 2nd. Happy May. We're the last month of school. Woo woo! All right, and this is for KAP. This is the last day of 6th grade material. We will have some lessons after STAR for KAP because there's some 7th grade stuff we haven't got to. But today's the last day of 6th grade. And spoiler alert, we've already learned this lesson. We're just tweaking it a little bit. All right, so we've already learned this lesson. It's just sort of rebranding it a little bit for junior high. So thinking about this first, how can we find how many cubes are in the base of this figure right here without just sitting there and counting? How could I figure that out? Dylan, how would you?
Multiplication.
And multiply what? What am I multiplying?
The up and the down.
The up and the down. The also known as the base and the height or something, whatever that is. Okay, so that would give you how many cubes. Are we good with that? Okay, then if I wanted to figure out how many total cubes are in this whole thing, okay, so this is 6 by 4, so there's a total of how many? 24. If I then wanted to find the total number in all of it, then I would
multiply by the height.
Multiply what by the height?
The base.
The what is the base?
Area.
We found the area of the base, right? And then, so when you're finding, what is this called when we find all these cubes? This is the volume. When you're finding the volume, basically you start with that bottom layer and you find the area of that bottom layer, right? We found 24. That bottom layer is just getting stacked and stacked and stacked and stacked and stacked. And that dimension, when I stack and stack and stack and stack, is called the height. And multiply that area of the base by however tall it is. Okay, and that gives me the volume. Do we agree with that statement? It's sort of a different way to think of it, but isn't that basically what we're doing? Yeah. Okay. We're taking that bottom layer, and instead of sitting there and counting 6,000 tiles, we're just saying, okay, it's that same one. Another layer, another layer, another.
That's 6,000.
I was exaggerating. It is a figure of speech. Okay. All right. So we would just use that to calculate all of the layers, and that gives us our volume. Okay. So give me a second. We're going to get into another. I'm going to pass back some stuff real quick. All right. So yes, volume of prisms. Today we're mainly looking at rectangular prisms. After STAR, we'll do triangular prisms. But this is all you need for STAR. Okay. So a prism pyramids are going to be nice for y'all. But let me finish. So the formula on our STAR chart, let's find the formula for rectangular prisms. Volume, put your finger on it. Find it with your finger, put your finger on it. Volume of rectangular prisms. What does it say? If you were looking at the STAR chart, it does not. Okay. One second. All right, that formula says V is equal to, and what's different about that V? It's capitalized, and it does mean something different. Okay, yes, really. Okay, because in elementary school, what was the formula y'all used? Exactly. Okay, it is actually still the same thing. They just tweaked it a little bit, and there's actually a reason that we'll talk about in a few weeks about why they changed it. But just know that if you did length times width times height, you still get the same answer. Okay. What's different about this was the capital letter. This capital V actually means the area of the base. We calculate the area of the base first, and then we multiply it by the height of the person. Okay. So if you think about it, again, relating to the length times width times height, to find the area of the base, you would do length times width, and then you're still going to multiply it by height. So you'll see how it's basically the same thing. Okay. The reason why it's different is because of triangular prisms, because it just says prisms, right? It doesn't say rectangular prisms, it just says prisms. It's because we can use that same formula for triangular prisms, for cylinders, for if you use any other, like if you did hexagonal prisms, like.
We do that in 6th grade?
Not in 6th grade, no. In 6th grade, we just do rectangular. Okay, yes, sir? Okay, moving on. So, what makes something a prism? Okay, maybe you know this, maybe you don't. What makes something a prism? First, it has to be a three-dimensional shape. Okay, it has a length, a width, a height. Good with that? Then, the other unique thing about it is that it has two parallel bases. Those two parallel bases will also always be congruent figures. Okay, so let's break down that whole. Okay, in a rectangular prism, it's three-dimensional, check, and then it has two parallel bases. Okay, so if I said the bases was the bottom and the top, are those two sides parallel to each other?
Yeah.
Yes, they would never run into each other. Are they also congruent figures? Yes, congruent means that they are the same. Those bases are the same. Okay, if I looked at a triangular prism. Sorry, this is my board. Oh, let me try that one more time. That was rough. That was real rough. If Miss Lila was better at drawing, would we have two congruent parallel bases?
Yeah.
Yes, they would both be, the bases would be what shape? The triangles. If I had a cylinder, the two bases would be the circle. Okay, are y'all good with that?
Okay.
All right, so that's the definition of a prism. Again, you don't have to do that, but it's just looking at it. The two bases in a rectangular prism, the bases are the congruent rectangles. Now, when you look at a rectangular prism, does it have to be the top and bottom that are the bases? No, okay, because what other pairs could be congruent? The sides, could those be parallel, and are they congruent? Yes, what else? The front and the back, okay? By default, if it doesn't specify, by default, the top and the bottom are going to be your bases. But sometimes it will say, hey, actually, the top and the sides are going to be the bases of the shape. So find the area of that. Maybe it's like a prism that fell over, something like that. In triangular and cylinders, the bases will always be the triangles or the circles that are a rectangle. It has a little bit of flexibility. Yep. It would be two, the trapezoidal prism. Nothing crazy. All right. Yeah. All right. So of course this is going to seem like a lot of extra work, but again, we're going to set the foundation with the easier problems so that when we get to harder problems, it flows nicely. So what's the shape? It is a
Rectangular.
good.
Oh, so good.
And the volume formula we just said was V is equal to
BH.
VH, but that capital B stands for
Area of it.
the area of the base. So the big B stands for the area of the base. Now, to find the area of the base, we first need to figure out what shape that base is. The shape of the base is going to be a rectangle. Okay, and the formula to find the area of the base is going to be, to calculate that area of the base, we would do base times height. I'm going to go with the one that's on our star chart, which is base times height. Yes, technically you can use length times width, but from last week we know it's base times height. Okay, so I'm going to find big B first, and then I'll substitute that into the volume formula. So starting with big B is base times height of this. Let's call, again, by default, the top and the bottom. How can I find the dimensions of the top and the bottom? Okay, how about I explain it? If this is 6, this would also be 6. If this is 3, this would also be 3. So I'm going to do 6 by 3. That's going to give me 18. I'm then going to substitute that into the volume formula. Volume is equal to big BH. So volume is equal, we said just big B was 18 times the height of the whole thing is 5. Where is that now?
60.
Yeah.
The volume is 90. Oh, and we skipped one.
90 inches.
So, sorry, I skipped this over here. So let's review real quick. Get a pencil, please. It's on your stop ceiling. Okay, let's review real quick. I apologize, I skipped this. So, volume, when we're calculating volume, we are trying to figure out the amount of what inside a 3D shape. We're trying to find the space. When you're calculating volume, it's another way of saying, right? Please stop. The space inside of that figure. When we find that space, we're looking for length times width times height. So if I did length times width times height, and they were all inches by inches by inches. Another way of writing that, my units would be inches cubed. So when I'm measuring volume, it is going to be in cubic units. Whether that's cubic inches, cubic miles, cubic millimeters. Okay, with an exponent of 3. So finishing this off, it would be 90 inches cubed. Okay, now of course Miss Isle doesn't expect you to write rectangular prism, rectangle, this is the base, blah, 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 blah. But I still expect you to do FSS. Okay, so I've got another problem. Again, I need to figure out the volume. So I'm going to say volume is equal to big B times H, but we're going to start with the big B because big B stands for area of the base. To find the area of the base, I do base times height. That's going to give me
10 times 4.
10 times 4. 10 times 4 we know is 40. And then I'm going to substitute that into that B is equal to big B H. So 40 times the height of the whole prism is 240 is the height of the prism. Slow it down. The volume of the prism is
240 feet.
Thank you. Are we good? Can we understand? Great. Do the next two problems. Okay, a lot of it can be writing the same stuff, so it's not that hard. Yes, the problems are harder with fractions. Oh my gosh. Are y'all big kids? Yes. Pause and play when you're ready to test. All right, so for this, so I still did a lot of this side because it was the same copy paste. But now that we're solving, when I solve for the area of the base, when we have two fractions, can I change those to decimal?
Yeah. No, but you can't do it.
Why not?
Because 2/3 will get it repeating.
2/3, that fraction, 2 and 2/3. 2/3 is what decimal?
0.6.
0.6 repeat. Can I multiply by repeating? No, so I have to leave them as fractions. So in order to multiply fractions, we need to change to improper. Okay, remember 2 and 2/3. Changing to improper, you can use Texas. 3 times 2 plus 2 gives me 8 over 3. Okay, do the same thing to 3 halves. That would be 7 over 2. Because I understand that fractions are taunting and blah. Okay, cross simplify. Where could I cross simplify? 8 and 2. Divided both by 2 becomes 1 and 4. Okay, that's going to give me what over what? 28 over 3. But am I done? No, that's just the area of the base. I could simplify there, but since I have more steps, I'm not going to bother. Okay, I'm going to go into my V is equal to big BH. I'm going to say V is equal to my big B, my area of the base is 28 over 3 times the height of the whole thing is 6. Okay, again, 28 over 3 is not going to simplify into a whole number, so I just left it, and I'm going to multiply it by 6. Let's turn 6 into a fraction. 6 over 1. Again, try and make your life easy. Can I cross simplify? Yes. 6 and 3, I can divide them both by 3. 3 becomes 1, 6 becomes 2. And then, hey, look, I've got 1s on my basis, so it doesn't even matter. 28 times 2 is equal to 56, and my units are going to be inches. Okay? Fractions really aren't that bad. You just have to practice with them enough to get comfortable. Okay? Again, I didn't simplify until the very end, because that way it's not overdoing stuff, because I had more steps. Questions? Not right now, so we're finishing up. Okay? If you have a problem, you're not going to get to go at all. Thank you so much. All right. Next one. Again, I understand if you do volume is equal to length times width times height. I'll do this one just to show you, but whatever. So length 1/2 times the width 1/4 times the height is 1/2. It's all fractions and it's all multiplying, so just go across. 1 times 1 times 1. 2 times 4 times 2. 16 inches. Okay. Even if you did big B times 8, you could still get that. More. If you add, you're adding, we are multiplying. Okay? All right, last one that we're going to do together. Number 2 on the back. Pause and read it. Read it on the back. Number 2 is on the back. What's different about this one? We have to find H and they give us volume. As always, we still start with formula substitute solve. So we're dealing with volume. Volume is equal to big B times H. Substitute in what I know. Do I know my volume?
Yes.
Yes, 102.9. To find the area of the base, it's a rectangle, so it would be base times height. What are the base and height of the base? Okay, so to find that area of the base, they did 4.9 times 6, and then times that h. Okay, to solve for h, couple steps. I'm going to go ahead and solve what's in the parentheses. I'm going to go ahead and multiply that. It's not that bad. Okay, what do y'all get? 29.4. So 102.9 is equal to 29.4 h. To get h by itself, divide. Take a second. It's gonna take a second. Map that out. All right, when I divide 102.9 divided by 29.4, can I divide decimals like that? No. No, I have to move it over, bring it up. When you do the math, what do y'all end up getting?
3.5.
3.5. Okay, 3.5, and my units are just going to be meters. Okay, so again, for your homework, we're not going to have time for our little activity. But your homework is the quiz day 1. It says day 1 in the title of it tonight. The rest of this paper is extra practice. Remember, tonight's homework is a quiz.